In this screencast, I'll show you how to use Java EE6 with OpenShift Express. OpenShift Express is a free platform as a service from Red Hat that allows you to use JBoss AS 7 amongst other environments. We're going to use the kitchensink quickstart from the JBoss AS 7 quickstarts, which are available for download from jboss.org. The URL is provided in the show notes. We're going to take a look at how you can deploy the kitchensink application. We'll then explore the application in depth. And finally, I'll show you how to create a new application. We first create our application using the rhc create app command. We're going to call our app kitchensink, and we're going to use the JBoss AS 7 cartridge with OpenShift Express. We now have to wait a couple of minutes while the application is created, the information populated to the OpenShift Express servers, and the Git repository into which we're going to place our binary is downloaded to our machine. We can see that a kitchensink directory has been created, which is a Git repository, and in it there is the options for source or binary deployment. We're going to be using binary deployment. We've also got the JBoss AS 7 quickstarts downloaded, and we're going to run Maven clean package on the kitchensink quickstart to build the war which we're going to deploy to OpenShift Express. We copy this into the deployments directory, and then using Git we add this and then commit this, and push it up to the repository. OpenShift Express works using a Git repository which backs your application. You can put your binaries in here, or you can put your sources in here. What we're seeing here is the sources for the root war, which deploys the landing page being built. If you were using source deployment, this will be building your own application. Of course, this build is just taking such a long time, as it's the first time Maven has run, and it is having to download all the dependencies. Future builds will not require to download all dependencies, and therefore will be much quicker. We can now use Firefox to take a look at the application. The application is accessed at the application name - your domain. What we see here is the default landing page for the application. We can also, of course, access our application, not just the landing page, by adding the context root path in. Here you can see the application has deployed, and we can use it as you would expect. Here we see an example of beam validation explored in more detail in a later part in this series. We need to, of course, correct our email address so that it's valid. The application also uses JAX-RS to display the data as RESTful endpoints, and a couple of these are displayed here. The sidebar on the right hand side gives you more information about JBoss AS 7, including the Get Started Developing Applications guide, which gives you a full tour of the kitchensink example and more. It also gives you links to the Java EE6 tutorial with extensive information about the Java EE6 specification and programming model, and of course more information about CDI. Next, we'll import the project into Eclipse. To do this, we use M2 Eclipse and the existing Maven project import wizard. The quickstarts are distributed alongside JBoss AS. We've downloaded them onto our disk previously. If you're interested in reading more about the quickstarts, check out the Getting Started Developing Applications guide for JBoss AS 7. It walks you through all the quickstarts, including the kitchensink quickstart we're looking at today. We also have JBoss Tools installed. JBoss Tools offers a number of CDI tools. These do things like validate your beans and make sure that they are correct. Autocomplete is also offered, so that you can autocomplete your injection points and also autocomplete the beans available from JSF. JBoss Tools also offers a number of other tools for working with Java EE, such as JPA JaxRS, and more. The quickstart also comes with an Archetype test. Archetype is a way of easily testing your project inside an application server. We're not going to go into any detail on how that works today, but check out the Getting Started Developing Applications guide if you're interested in learning more. Next, we'll take a look at how JSF is used in the application. As you can see, we have the facesconfig.xml. This is used to indicate to the app server that JSF should be used. We have a simple HTML page that kicks us into the app using a meta refresh. And here you can see the JSF page. We have a number of components, for example these input text components you can see, which are bound to various backing beans to submit the data. The data is submitted using the command button. We also have a table which is used to display our JaxRS endpoints that can be accessed. Next, let's take a look at how EJB and JTA are used to provide transactions in the application. If you open up the member class, you'll see that it's a usual JPA entity annotated with @entity. There are a number of other annotations like @ID with a generated value and a number of getters and setters. Just what you'd expect from any JPA entity. We can now open up the member registration controller. This is a view controller and it's responsible for persisting any new members we add to the system. You can see that we use the entity manager and call persist just as we would in any Java EE application. Something a little more exciting happens in the member list producer. This is a data access component and it uses the criteria API introduced in JPA to display all the members in the database organized by name. The criteria API we're using is a standard criteria API using strings to refer to property names. However, if you prefer, JPA2 does offer a type-safe criteria API. This quickstart allows you to experience that by uncommenting the type-safe criteria API code here. We can also use the entity manager in other locations such as servlets or, as for example here, in a RESTful endpoint. Here we're using the entity manager to load members as required from the database, both to display a list of members and to load individual members. You may be wondering how we're able to inject the entity manager using @inject rather than @persistence context. CDI defines the resource producer pattern, allowing us to alias an entity manager injected using @persistence context, so that it's available using @inject. Next, let's take a look at how bean validation is used in the application in order to enforce our constraints everywhere. First of all, let's take a look at it in action in the UI. Here we enter an invalid email address and hit register. We'll see that there are error messages correctly attached to the various fields in the UI. Of course, if we correct the email address and the telephone number, the validation will pass and we'll be allowed to submit the form. Switching over to Eclipse, let's take a little look at how this is implemented. First of all, we're going to open up the JSF files that define how the view is implemented. We can see here that there are in fact no references to bean validation at all, nothing to attach various validators to various fields. We simply define the fields and bind them to the backing beans. This is one of the great powers of bean validation in Java EE. It's automatically activated for you and applied to fields where you define your bean validation annotations. The annotations are all placed on the model class. Here we can see various examples, such as email, length constraints, and pattern constraints. Next, we'll take a look at how JaxRS is used to provide RESTful endpoints for our application. Here you can see a list of all the members on the system, and we can also access an endpoint for each member. With JAX AS, this is really pretty easy. All we have to do is annotate a few methods. If we open up the JAX AS activator, we'll see how we can activate JAX AS for our application. Of course, the real work happens somewhere else, in Member Resource REST service. Here you can see we annotate a path onto the class, and we also annotate a method with the get annotation, which allows us to display all the members in the system using a simple JQL query. JAX AS takes care of converting from an object format to XML using JAXB. Next, we'll take a look at how we can use CDI to wire together our application. CDI offers loose coupling with strong typing. Here we can see the member registration bean. It's a request scope bean, and it uses the model stereotype to declare that request scope. Stereotypes allow you to collect similar sets of annotations defined by CDI onto a single annotation, thus allowing us to collect together common patterns or stereotypes on a single annotation on the class. Otherwise, this is a fairly straightforward class. Let's move on to the member list producer. Member list producer is responsible for access to the database via this query, which retrieves all the members ordered by name. This is used on the main page in order to display our members. We also, of course, have a JAX AS service that allows us to display our JAX AS listings. You'll notice here that we've decided to put the query directly into the JAX AS component. That's fine, but we might decide that we prefer to keep all of our data access together in a single bean. We can easily do this, and this allows us to show how we can refactor very easily using CDI. What we'll do is copy the query to the clipboard and remove it from this class. We'll use an injection to access the data, which is going to be coming from our member list producer, and we can give it the type of a list of members, and then of course we can simply return this from the JAX AS method. This makes the JAX AS class much simpler and responsible for a single thing, exposing data as a JAX AS endpoint. So if we switch back to member list producer, of course we're going to need to create a method that does return this data. Now we could decide to use the existing members query, but we want to display them ordered by email. So what we can do is adjust the query that we've pasted in from the JAX AS class to be ordered by email by adjusting the JQL. And we can then adjust the method name to reflect the fact that we're now ordering by email. So now we need to use this query that we've exposed via the producer method. And you'll see that when we go back to the JAX AS service, we're almost there. Before we go any further, I want to elaborate on something I mentioned earlier. CDI is a type-safe dependency injection system. But what does this actually mean? Well, what it means is that CDI, when it tries to resolve what a bean to inject for an injection point, will first of all look at the type of the injection point. So if the type of the injection point was, let's say, foo, then it will go out there and look for a bean of type foo. Of course, you can have more than one bean of type foo. This could be when you have two classes that implement the same interface and you try and inject that interface. Of course, there are many other scenarios in which you can end up with a similar situation. CDI provides a number of ways of resolving this. If you know at development time, when you're creating the application, which bean you want to inject, you can use a qualifier. This is an annotation you place both on the injection point and on the bean and allows you to disambiguate the bean. If you know at deployment time, i.e. when you're packaging your app and putting it in the application server, then you can use an alternative. Or, If you don't know until runtime, you can use a producer method. Here we're going to use an alternative to disambiguate between the two implementations of member lists. Here we're using the JBoss Tools wizard to create the qualifier, and we call it sorted by email, and we put it into the data package. A qualifier is simply an annotation that's used to disambiguate between types. Having created the qualifier, we can add it to the injection point, which will mean that the error that JBoss Tools gives us changes. Of course, we also need to add the qualifier to the bean, to the producer method that's being used to create the data. We can see this in effect if we add a new member. And we can see that the list of members on this page is still being sorted by name. However, if we view the REST query, we find that they're now ordered by email address. So our reordering took effect, and our refactoring also worked well. That concludes our tour of Java EE6 features. Next, we'll take a look at how you can create your own Java EE6 application for OpenShift Express. OpenShift Express offers both binary deployment and source compilation mode. We'll first of all take a look at how you can create your own application in binary deployment mode, and then we'll take a look at source compilation mode. First of all, we need to create a new application on OpenShift Express. We're going to call the application Acme, and we're going to use the JBoss AS 7 cartridge. We've already associated our account with a domain, so all we have to do is create the application. As this deployment is going to be a binary deployment, we're going to place the war in the deployments directory. We're going to use Eclipse to create the project using a Maven archetype. We select the Maven project archetype wizard. We now need to set up the JBoss Maven archetype catalog. And then select the correct archetype, which is the Java EE6 web app archetype. We're going to give the project the correct group ID, com.acme, and the artifact ID, acme core. And we'll put all of our classes in the com.acme package. As you can see, the classes are all exactly the same as in the kitchensink quickstart, except that this time they are in the package that you select, and various resources are also customized. We can deploy this by switching into the Acme core directory that was created by the archetype and building the application using Maven package. We then copy the war into the OpenShift deployments directory. Commit it using Git. And push this to the OpenShift servers. The build that we're seeing happening now is the default application being built The application has now been pushed out to the OpenShift servers, and we can access the application in our web browser. As you can see, the application has successfully deployed. Now we'll create the same application, but rather than using binary deployment, we'll use source deployment. In this mode, the sources are uploaded to OpenShift Express, which then compiles and deploys the project for us. First of all, we need to create a new OpenShift Express application. We're going to call the application Acme, and we're going to use the JBoss AS 7 cartridge, which gives us access to the majority of features in Java EE 6. In this example, we're going to use source deployment, so the first thing we do is clean up the example application that OpenShift Express gives us. OpenShift Express can compile and deploy any Maven project in source mode. To create the project, we use Eclipse's new Maven project wizard. We need to add the JBoss Archetype catalog, Once this is added, we need to select the Java EE 6 web app archetype. We're going to call our application Acme, and we're going to give it the group ID com.acme and put all our classes in the package Acme. This project contains exactly the same classes as the kitchensink quickstart application, however customized for your package name, your group ID and your artifact ID. As we're running in source deployment mode, we need to add a couple of items to our pom.xml. First of all, we need to change the output directory to be the deployments directory. This means that when Maven runs the compilation remotely on the OpenShift server, it will copy the war created to deployments. We also instruct Maven to output the file as root.war. This means that JBoss AS 7 will pick it up as the root application, meaning we don't have to enter a context path. Having configured the POM correctly for remote deployment, we now add the files to Git, commit them, and push them up to the OpenShift server. The app is then compiled remotely by Maven. Now let's take a look at the application in action. As with the kitchensink sample, we can create new users, we have beam validation wired in, and we have a JAX-RS endpoint. This should provide you with an excellent starting point upon which to go and build your own application. In this screencast, we've learnt about how to deploy an application to OpenShift Express, how you build a Java EE 6 application, and how to create your own application.